Good morning, good afternoon, good evening. I'm Zafar Taqwi. I'm chair of the ComSoc chapter at Galveston Bay section. And this presentation is the second of the two presentations that we have during this week that we call ComSoc week. And as we know, the ComSoc is one of the most active societies. And of course, I've got the director of the North American region, who is the speaker here right now. The topic of smart cities and smart societies is kind of a very timely topic, because now everything is becoming smart. We need to bring in the intelligence in the system so that it can work. And of course, the speaker is an author and lecturer. He has authored a book on collaborative Internet of Things for Future Smart Connected Life and Business. He is the president of the TelNet Management Consulting, that company that he formed. He is an author, a lecturer, and of course, as I said, he's the director of the ComSoc in a regional board. A lot of things that I could talk about him, but I think the key part that I want to really emphasize is the various executive positions that he has and the leadership positions that he has been and he's continuing to do right now. Not only for the ComSoc, but the society itself, for the section that he is a member of. He's chairing several other societies and providing that kind of support. The other thing that I just cannot believe how he does it, but he organizes the various conferences. And if you look into the list of the things, last 12, 15 years, he has organized the various conference on the wireless communications, on the blockchain, on smart city activities, technologies for the healthcare, and things of that kind, which is really very, very rare. He has the Bachelor's of Science degree from Concordia University, and a master's in computer science from University of Waterloo. And also he did the executive MBA from Queen's University. I have got a whole list of the awards that he had been bestowed upon by the IEEE, by other organizations, but I don't want to take thunder from him. So Fawzi, this is all yours.
Thank you so much, Zafar. Thank you for the opportunity to speak to a diverse audience and passionate audience. And thank you for participating and attending this webinar, if we want to call it this way. But I have really the pleasure to prepare some information that I think, as Zafar mentioned, touches all our lives now and in the future. And it is becoming more of a complex world. And if we have a clearer view in terms of what direction this world is taking us and how we can prepare for it, I think we'll be in a better shape to enjoy life and every minute of it. So live the moment is really what it's calling for. The talk itself, because it is a complex subject about smart city and it encompasses many things, I'll touch roughly in terms of defining it or set some boundaries about the smart cities, look at the enabler technologies, disruptive technologies as one key area, and then provide some examples how this will take us. And then as we all witnessed, COVID-19 did touch everyone worldwide. And has it helped or has it hindered the progress in terms of moving towards smart city in terms of acceleration? That we'll like to address at least in a couple of slides, and then cap up with the key points that we got so far. So I have presented the prepare the material. And this is really roughly what Zafir has indicated, and I don't have to repeat what it's mentioned, but all I could say is that my background has been industry and with touch with academia, so it's really has grown that way. And I stepped back and tried to offer much more quality service with the consulting company, and also opportunity to put some things in writing, like as in the book, or as well as lecturing and basically trying to generate awareness and help people to understand where we are and how we can leverage the uh, technology that we have and improve the quality of our lives. Different sources that I have relied in collecting the content and the material for this webinar. And so this, you will see that more as you will get a copy of the slides. So you don't have to take any kind of notes. I structured the presentation into these areas. Give you an intro to the smart cities, and then the technology that's influencing the evolutions of smart cities, and provide some examples, and then how COVID-19 is situation with respect to where we are today, and takeaway points. So let's start. So number one, in terms of a smart city, and one is, I will take that as a story flow. So I will dwell in some slides. I will skip through quickly in other slides. Again, you will have the material, but the most important thing is really to get the essence of the talk and how it is positioned, so that you could see where we are. So we all live in cities and communities, and we have mayors and that really looking after us essentially, and they have major tasks in terms of improving the economic situation in our area or our city, as well as a citizen, they're also looking after improving the quality of our lives, and also with introducing technology and building systems that will help us to accelerate and be efficient in what we're doing, but more and more really sustaining that all infrastructures. And that does not really restrict in one particular domain and one particular sectors, but across many sectors. So they are engaged with, as you know, with transportation, with traffic, engage with in terms of the safety of the citizen, the safety of in the environment, etc. Also looking at the whole gamut of in terms of energy and water waste and all that. How is it perceived from a smartness perspective? And that touches also in the whole arena of living and building, whether it is for residential or businesses or factory and so on, and many other aspects, the health, the educations, the finance, tourism and leisure, retail, logistics, manufacturing and construction, and of course, overall government. So as you can see here, it's a diverse vertical markets that we try to cross using the technology to provide some unified approach and hopefully more integration, more consolidation and integration, and then adding intelligence to that. So what would be the image and the pictures of what we really are calling for? And this is really what you see progress differ from one city to the other, and from one community, and from one state, and from one government. But essentially, it's all boiled down to areas where we live in terms of home and residence, the area where we work and produce products, and so on, in terms of manufacturing cars or materials, and etc. in terms of industry, and of course the whole arena in terms of commercials, in terms of building and governments and campuses, education, etc. And of course the whole business of from home and multi-dwelling area, not only providing intelligence within each and providing a network and connectivities, but also providing an overall interconnections between these islands of areas of where smartness is being applied. So the sectors that he described earlier could be exemplified in these types of islands. And then you have an overall operational support all the way from looking at it from the market and directions, look at it how the services are carried and distributed, and how the services are being carried out and operated, and also administered, and providing support to people. So again, the whole arena in terms of emission is enriching the personal productivities, improving efficiency, and improve quality of life. This area of smart cities is quite large and huge market. So you look at it from revenue, we're talking about $2.5 trillion and by 2025. And you could see tremendous growth from one year to the other. This is just showing the and at a double-digit rate in the 20s plus. That's essentially what has been described here. There has been a study that's done to look at the. I'm getting a tab here. I'm just trying to see if I can hide this. Okay, here we go. Just hiding the information from me. Couldn't read it. Now, so there has been a study done worldwide about the smart cities. They look about 600 cities, and they look at it from GDP perspective and what would be and define some criterias and look at it what would be the pictures by 2025. And these 50 cities, there were 8 in North America, 13 in Europe, 6 in Middle East, 16 in Asia Pacific, and 7 in Latin America. And they examine it from 3 areas: sensors that really detect where we are and where the changes would be, and monitoring that, communicating these types of information that are coming through the sensors and bringing it in terms of correlations and extracting data, and by sending it through kind of open data portal, and in more or less generate insights and make up more informed decisions. They have valued each studies at 37 points. So anything sort of halfway or more is really bringing these cities to be like the top tier that we could that shine worldwide. And so these cities that I have listed before are exemplified. Maybe it's hard to read, but at least you get a sense of it in terms of those 8 cities in North America, Asia Pacific, Europe, Latin America, etc. And you could see, for example, also look at it from sensors, communications, and open data, which is what you see here in the tab and in the bar, the shaded color. You will see, for example, New York City scored 24.4 out of 37, followed by San Francisco as a second in rank, etc. And Austin, I think, did not make it at this point. But you would see also the same thing for Asia, headed by Singapore and Seoul. In Europe, Stockholm and Amsterdam. In Latin America, and I see the Latin America and Middle East are really below the midpoint. So Sao Paulo is 13 out of 37, and Abu Dhabi, for example, is 18 out of 37. But it gives you a flavor of each, and provided one slides on each regions to give you a little bit more details as far as the details of each cities, and where the mixture in terms between sensors and communications and the data portal. So these are all important to help and formulate a model to go forward. So the same thing really applied for Europe and Middle East and Latin America, as well as Asia Pacific, same type of structure. So what this means? So that means if we apply in these major ingredients in terms of sensing and communications and services, as you could see here in the left-hand side, we see that if we look 10 years ago, I mean, you'll see island of companies really focusing on one area or one expertise, which is, let's say, sensing, another area dealing with communications and networking and gateways and all that. And then you see companies really focus more around offering services. So this has been island by themselves, they're discrete and segmented type of solutions, but more and more we see these moving towards the right of closing the gaps between these areas, between sensing and gateway and services. Not only that, providing linkages between these points so that they can get more informations. And you have multiple of these types of point solutions. And then as you move to the right, now we have more coming towards consolidations and integrations. So now you can do quite a bit of all these sensors could be correlated, let's say at the gateway level or at the edge level, and more insightful information could be generated in the cloud and offering much better type of services. So that's really a very highly simplified model that I did describe in the book that Zafar has mentioned. And likewise, this particular model that was also described mainly to illustrate that there's to simplify this world. I mean, we're still looking at four major ingredients to come up with smart solutions, ensuring that we have a quality of sensors and a variety of sensors, and have these sensors communicating the data to the next level, which could be the edge at this point, and that could have different degrees as to where we are. Could be edge computing or edge AI, like when in let's say 5G and 6G, and as well as data could be moving to the next level for data centers or big data and applied deep learning and machine learning and so on, so that you can apply various types of control, and you go down to control at the edge level as well as down to the sensor level in terms of control. So that's a high level type of simplification, but it tried to embody and the whole disruptive technology of IT and cellular as well as intelligent analytics. So that's give you a quick just introduction to the smart city. Now I want to talk about this technology, disruptive technology that's are shaping and moving and how they are being adopted, and look at the use cases and then look at the impact from COVID-19. So we talked about sensors, and as you could see, they are accelerated. There are all types of sensors, from biometric sensors to health and environment sensors, to image sensors and light sensors and so on. And as you see, there is a continuous growth. This is really old slide, but nevertheless, it highlighted the growth potential of sensors and the market that really billions of units have been deployed and will continue to accelerate in terms of deployments. There is no shyness in terms of having these intelligence and sophistications that are being built into the sensors. Some may have some intelligence for local storage. Some may have intention to collaborate intelligently with the next level, which could be the edge and so on. So, but also the whole notion in terms of IoT to bring the information from, let's say, previously you call it passive objects. I mean, your desk, your computer, all of these things are living by themselves, but the minute you start to connect them and make them intelligent, the more you could start communicating and get more results. And this market itself has been growing tremendously, as you could see. 2022 looking for $500 million, and if you look at the 2025, we're looking about 1.5 billion dollars. Trillion dollars, sorry, I apologize here. So there is a tremendous growth into that market, and because it is also applying across all sectors. So if we look at the smart city and all the sectors that they are addressing, and imagine the amount of sensors that is needed, and you will see some examples how many sensors we have in the past in cars and how many we have today and how many could we have in the future, etc. I'd give you an example. Same thing for the homes and transportation, etc. But the arena of artificial intelligence and the machine learning and deep learning is really is playing and continue to play an aggressive role as we go forward. Not only to help to identify where the problem is and what happened, but also why this is happening and what could happen in the future. So give you some level of predictions, and then how can we achieve the best outcome. So as you could see here, it goes through a growth in terms of adopting various types of algorithm and tools that will help you to really not only storing the data, but analyze the data and projecting the data and compare and come up with much more intelligent solutions. And it's not only applied to the system itself and the component of the system itself, but also applied to the applications. So that's another big things. And the market, as you could see here, is growing to about $98 billion by 2023. I'll try to run through it quickly so that we have more time for discussions. Take a notes of the questions that you like to ask, and please feel free to put it in the chat, and we'll be happy to respond to it. All of these things are coming together, and the one that's really putting it all together is 5G, and this is a huge market, looking about $13.2 trillion by 2035, because it again, from a smart city perspective and other approaches, it is touching a lot of sectors, from agricultures to mining to education to healthcare, um, to mobile experience, smart manufacturing, intelligent retail, and smart city. Not only that, but it quantify how the market is going by 2035 in these particular areas, as well as show you where some of the examples, how these things is going to impact and kind of improvement is putting. So all I could say is that 5G is putting as a unified technology to pull all of these things together and come up with smart and aggressive type of solutions. Consequently, from 1G to 4G, concentration has been really in things like speed and latency and so on, all types of performance type of data and reliability. But with 5G, they added a whole gamut of things, and basically they start looking at the use cases and how such a technology going to impact and improve things. And they started putting specifications from 5G, not only looking at the performance aspects, but also look at the impact and the use cases, whether that could be Internet of Things or sensors network, smart home, grid, transportations, on-home gaming, virtual reality, medical sensors, all the things that we talked about that are also the ingredients and building block of a smart city. 5G vision and impact is really going to address that, and 6G is going to come and add much more to it. Typically, as you could see here, 5G takes about 10 years cycle. So we started in 2020, and probably by 2030, we'll have a much more mature, scalable type of solutions. But prior to that, let's say in 2028 or so, or actually we started now, we're doing introductory visionary statements about 6G. We'll have much more clarity as 5G is being deployed, and midterm, they call it 5G advanced by 2025, would have some ingredients of defining initial spec for 6G, and then start building the scope and the specifications onward, so that by 2030, we have a spec to start working with and deploying the 6G. Prior to that, we had the 4G and of course the 3G. As you could see here, the initial generations focused on voice, then followed by data, and then now we're moving more in terms of collaborate between type of informations, remote control, and moving forward actually to adding much more things into the like taste and smell and all of these things, you believe it or not, is coming as part of 6G. So now that we have just a global view in terms of the high level roadmap, and there are a lot more details in terms of roadmap that we could share in future presentations. If we just step and look at now the performance side of it and compare 5G against the current one, let's say LTE. So here you compare 5 performance parameters: the latency, throughput, connections, and mobility. You see, really at this point, we're running about 30, 50 milliseconds in terms of latency. This will be really improved by 30 to 50 times, and to ideally will go down to 1 milliseconds. Probably today we are 10, 15 milliseconds, moving towards 5 milliseconds, which is really needed in the healthcare all the way coming down to 1 millisecond. So you will see that this will not happen overnight, but we have 10 years that every 2, 3 years you will have gradual improvement, reaching from the 50 milliseconds to 1 millisecond. Similarly, in terms of throughput, running today at roughly about 100 megabit per seconds, and per connections, and ideally the aim is to get a throughput to 10 gigabit per seconds. That's 100x. Again, that will happen over time. Overall, in terms of density connections, we have about 100 K in terms of connection per kilometer square, and we're looking at about 1 million connections. And the same in terms of as you travel, you still want to maintain services at a higher speed. So there are calls for improving speed or sustainability, I guess, of services, all the way from currently, let's say, 350 kilometer per hour into the higher type of speed, 500 kilometer per hour. So there is a tangible performance improvements that 5G is offering. If we get a glimpse in terms of what 6G is offering, and just look at the focused area. So, and it will be much more ultra fast, focusing a lot at the edge, continue to look at lower latency and a real-time perspective, but also from IoT perspective, it's really providing huge number of connectivity, adding more devices and more in terms of interoperability and sensing, and also in terms of data AI will apply a great deal in terms of smart operations, insightful from data type of situation context. So the vision here, and according to one of the consortium that has been driving vision for 6G for 2030, it is really ideally want to achieve 1 terabit per second speed, microsecond latency instead of 1 millisecond latency, and AI optimization. So that's a huge a shift from what 5G is delivering. So that's again another momentous journey that we could witness as we go from transitioning from 5G to 6G. So let's look at some examples, and because that help to give you a little bit of are there things done, or it's just on paper. And this is really what I wanted to do. So first of all, it's always to have a reference model, because with that you could see where we are and how we're positioned and how we're moving ahead. And a lot of core 3GPP, ITU, and of course IEEE and many others have really focused a lot in terms of how we can help and collaborate to bring about a greater vision for 5G, and especially in terms of use cases and framework. But ITU took a lead in terms of defining the framework as a triangle, as you could see here, heading with what we have been witnessing before, which is really mobile devices. And then they look at how we are going to enhance the mobile broadband, but also looking at how things like IoT and massive machine type communications. Oops, touching is, there we go. So sensitive here. Is going to traverse in terms of many things, in terms of smart home, voice, as well as a smart city. All of these things really going to apply, just going through that direction in terms of massive type of IoT. If you look at the right-hand side, is looking more in terms of mission critical. So this is really where, hey, about introducing not only high definition video, but 4K video, work and play from the cloud, augmented reality, industry automation, mission critical automation, self-driving car. All of these things really require much lower latency, a higher reliability, and communications. So as you could see, we have the work framework already established in terms of how we move forward. Certainly, we cannot just jump and have the application right away to deliver ultra reliable. I think these are the things that will come mid 2025 onward, after 5G advance start coming into tuitions. but we have a lot of areas to build ingredients and components and building blocks in the other areas. And so therefore, I'll try to touch these types of three groupings in terms of one thing will be headed in terms of enhanced mobile is the whole notion of video streaming. And it is really, anyhow, eliminating all types of caching and buffering and all that, and providing smooth type of streaming of things that could be could be in real time. The whole notion of massive Internet of Things, how these things are connected and scalable, and of course in terms of machine to machine communication and mission critical type of applications, as you could see in the right hand corner. So there are a lot of applications that we could look for, and here we could now start looking at coming up with different generations of devices, number one, for mobile devices, and started with iPhone, let's say 10, and then 12, and now announced iPhone 14. They all come in different shapes, but also coming with different features and enhancements, such as, let's say, iPhone 12 here coming with the sub 6 gigahertz millimeter wave, triple camera, advanced LiDAR, and also sensors for augmented reality and greater depth of sensing. And the same thing with LGE and Samsung and other type of manufacturing. They are expensive, but the aim is really to get a much lower pricing point that people could afford, and basically try to keep, as they move from one generation to other, to keep the price the same, but increase the number of features. So some of the things we'll see impact, as we already witnessed. If you look at 2-hour video, standard definition type of video, if you look at 3G, it takes about 26 hours. You can travel, let's say, from here to Singapore and come back, and then that video is still being downloaded. And if you look at it, 4G adoption, then it's really calling for 6 minutes of download. And now if you look at 5G, you're looking at 3.6 seconds. So now you could see the tremendous advancements in terms of cutting short the performance and from streaming and video perspective. That's why video will become quite a disruptive and wide spread type of application and diverse type of sectors. And we saw the witness of the drone coming in. Now more regulations are coming into play, but the imagination in terms of use cases on unlimited. Here are just a highlight. Could be used for combating fire, in terms of ambulance drone, and for people maybe got stuck or got some sort of a heart attack in resort areas, you can deploy a drone, and with some instructions and help, you could help maybe bring some people back. These are all, we could witness it through Google. In terms of agriculture, how we achieve much better results in terms of crops and precision agriculture, and of course in the whole arena of disasters and recovery and so on. There are a lot of aids that drone can help with, certainly. And as we witness in terms of cars and transportations, moving more from a smart car and to autonomous driving. So today we have a lot of gadgets in the car that help you to stay in one lane and give you warning in terms of if you speed too fast or against, let's say, objects on the road, give you pedestrian alert or traffic hazards, or ensuring more or less safety in driving. But as there are about 5 levels, and right now we're in level 2. Level 5 is really getting into autonomous car, basically the autonomous driving. Basically the driver is really letting the system handle the things. But right now, to go towards that level 5, there's all types of contingency activities and scenario building and avoiding various types of disaster that have been maybe witnessed in various trials. So it is a painful road, but it is a promising road in terms of safety and productivity, if you want to call it that way. The whole arena in terms of healthcare is also promising. and especially from a reliability perspective, latency and security and safety. Uh, so there is outer shaded area here in green is representing the kind of applications that can be deployed and where we are today in terms of 4G. So we're more improving in terms of living, patient monitoring, and help in terms of prevention, but focusing going forward in and excelling in the area of telehealth, telehealth care, and certainly the pandemic, as we see the COVID-19 help accelerate that to a greater extent. Public safety and our first responder is another major area where you can bring all these types of technology from camera to sensors to driving, transportation, etc., all coming into one play and build up effective strategy to combat. So nowadays we could see it um, deploying, let's say, early drone to collect informations while you are preparing your combat strategy, studying the schematics of the building and the area being affected to bring about the identifying the risk and how we are going to combat that risk. I'm running through here quickly just to give you the high level pictures, but there are other things we can cover in more detail down in the future. So 5G essentially, this is just to give you some examples, but there's a lot more that 5G can be deployed in terms of broadcast type of like services, um, lifeline type of communication, natural disaster, and all types of sensors that we see in terms of taste and touch. We will be seeing shortly. There are some experiments around that area. Where would that lead us? So this is really a nice picture I liked that give you the beginning of 2020 with 5G and showing that these are previous generations of cellular plus wireless, um, Wi-Fi and so on, and also fiber to the curb, fiber to the in terms of fiber transport systems, how these things are evolved and how architecture evolution is deployed to bring about greater level of lower latency, throughput, as these are the elements that they did highlight in terms of 5G benefits. But essentially, as you could see here, as you apply to different sectors from a smart city perspective, it definitely have impact in terms of the social value, because it does bring an open platform for innovations that will not only help the consumer, but the customers, but also the people that investors and the partners that are adding value, are investing to get much greater value. And that's overall will improve the overall social value creations from safety and the quality of life, as well as industry, which was really the initial mission of what I mentioned in terms of what the mayor of a city is striving to do. So that brings us quickly to the COVID-19, and I know these have been touched everyone in a big way. I mean, suffices to say, I went last night um, to pick up the latest statistics and from John Hopkins because they have been tracing and tracking it from day one. Just and they can you can have it globally, you can have it by country, you can have it by region, by city, you name it. There's a much more granular type of information. But at the high level, I mean, the COVID-19 has really provided confirmed cases of 611 billion type of cases, and but also unfortunately resulted in over 6.5 million deaths globally, and specifically in US it was over a million deaths, and also over close to 100,000 or 100 million confirmed cases for COVID. So as you could see here, it does not leave anyone, whether you are vaccinated or not, you could still be subject. So it's a vicious virus. Vaccination is helping a lot, and now we're going to a series of um, uh, booster now, a second one that is really helping out, maybe especially the elderly, but they are also trying to administer it from um, younger generations to mid-age to senior. So essentially, the impact is horrific, and certainly that came at a time that where we are pushing hard in the 2020, starting with 5G, and right away, did it put a stop? Maybe you could say yes, it did put a little pause, but it also generate awareness that people start looking at things differently. They start and being, instead of being locked down and so on, they start looking, okay, so what does it mean? The environment we live in is, do we have a clear, how is our ventilation? How is the indoor quality, for example, the dust and pest? And also in terms of security, the water quality, the thermal health, the moisture, the lighting, the acoustics, all of these things, parameters really create a greater level of conscious that many institutes have started building with researchers and um, prototype systems that help seeing how we can go about automate areas such as in energy and make it more optimized, um, and cloud based on cloud for remote services. We look at things from heating, ventilation, and air conditionings and indoor quality, as I mentioned. What are the key ingredients that developers as well as the look for in terms of building the system, along with the maybe modifying the civic code that may require so that we could adjust our life. And we certainly see much set of even list of things that COVID-19 has generated that's being really looked at different areas. Touch-free toilet seat, for example, the nanotechnology-based self-cleaning service, and so on. As you work backward, you will see a lot of occupancy detections based social distancing and so on. All these types of ingredients that we and tools that we wanted to build or are building will help improve to minimize the impact if this is happening again, to minimize the hospitalizations and ICU and so on, and improve recovery and faster back to normal type things. But we saw a lot of accelerations, especially in the area of teleservices in terms of technology adoptions, monitoring of devices, and reporting data both to the user, to the doctor, to the institute, to the cloud, and generating a whole connectivities between remote monitoring, collecting the data and remote monitoring, and scaled technology so that we could have much more collaborative and build scenarios that really deliver much more effective type of solutions. And we start seeing ingredients in terms of having what's called smart hospitals with with monitoring in terms of when a drug is available, getting the code of the drug, the time it is administered, who administered it, and so on. So you have a closed loop type of administration of drugs, readings of from various instruments, integration of various devices, so that the both the patients and the nurses and the practitioners and so on have a look and collaborate with the patients to come up with the best scenarios type of for solutions and recovery. So there's a lot of lessons learned being locked down and slowed down. So yes, it did force us all to be in one place, running things remotely and the conductive work from, let's say, from home. But it helped also accelerating the adoptions, out of adopting the technology for remote operations and actually at an unprecedented scale. We know that travel had got to a halt, but now it is coming back to normal, not full normal yet, but pseudo type of normal. So we learn a lot from that. We used a lot of video conferencing. Now we could see a lot of hybrid approach maybe will be used in the interim for the foreseeable, the next 2 years or so, before really we come up with an even more enhanced back to normal type of solutions. Things will manifest itself in a better way with the better results. even in the office, and how to manage staff, how productivities pay, as we witness a lot of people calling for strikes and so on because of working conditions and inflations and all that. So all of these things are really is shaping up, and certainly COVID-19 helped accelerate and we became more conscious of what's happening, impacting business, so that we can look at ways that should be able to drive business more efficient and provide better output to the workers and to the employers and the overall industry and governments. So basically that give us a quick rundown, and what we stop here and say, so what have we learned so far? Certainly there's technology, and that technology accelerating. We saw IoT is growing fast from a market perspective. Same for 5G and AI across all types of markets. We see the performance itself, and from 4G to 5G, and what the aim of 5G, and we had a glimpse of actually of 6G, what it is called for in terms of performance, but also in terms of impact, not only in current use cases, but also generating a whole class of use cases. Now we're also looking at the collaborative technology. So these things are not staying in silos or isolations, but you see the things coming from IoT are interconnected also with the communication systems as well as with AI and so on, to provide much more insight analysis and better insightful information for decision making. And what to cap it this more, I would say COVID-19 really helped accelerate the adoption of the use of technology. It maybe have put a little pause and dent initially, but I think there will be a quick recovery to the roadmap of 5G, and perhaps more acceleration so that we can achieve more, and give you even shed light in terms of what we could anticipate for 6G, because we learned a lot about things in a way that will be integrated in 6G, whether it is satellites or things in space, or as I said, taste and smell and all types of things and environmental things that we can be added. All of these things help us gradually to move towards managing the environment that we are in an integrated, consolidated and integrated form, and also from remote management perspective, and apply that not only to cities, but also down to the community level, urban as well as rural communities, and then to the states and well as government and intergovernment. These things will be applied to help bring about a much more smarter type of society, intelligent and based on a smart systems. This is a book that Haraz Zafar mentioned. I was co-author, called The Collaborative Internet of Things. A lot of material that I do cover, the basis of it are really are in this book, and we do have discounts for IEEE and other members. So really, first of all, I wanted to thank you for your attention, and also taking time to see what this technology, hopefully the information has been useful, and give you a bit of roadmap and pictures of what how smart cities really is going to touch all our lives, and how we can prepare for such adventurous and take it more of an enjoyable type of journey. So with that, I pause for any maybe I know we started a few minutes late, and we have maybe a few minutes for questions. So I'll return the control back to Zafar.
Yeah, and thank you, Fawzi, for a great presentation. I tell you, when I look at the emblem of IEEE, it says technology for the service of humanity. And then what you presented was basically what it was, service for the, technology for the service of humanity and all aspects of it. I think this is a great way to go back and start looking at all the things which are really going on in the advancement of the technology. So we have a couple of questions, and those who are asking questions, you can unmute yourself of course, audio and video so that we can see and ask the question. Looks like there are a couple of questions there. Dr. An Nguyen has asked in the slide mentioning the evolution of 1G to 6G correlation data. That's the question that Win has.
So I'm not sure in what context. Certainly there is the data that are collected from sensors. They are not, if I'm collecting data from, let's say, the wind, let's say I'm in base stations, running base stations, and this has a lot of subsystems. You have the wind, you have the precipitation of rain, you have temperature, and you have the transmit and receive chain, for example. All of these things are standalone subsystems, and they all have type of sensors to detect where we are and control each individual type of parameters. But it is important from operation of that subsystem, let's say the base stations, is to correlate if I have such a speed of wind that's coming on, and if there's no rain or with heavy rain coming in, and other parameters, definitely we need to correlate the data that are coming from these systems. So it's a next level up rather than seeing discrete type of data coming in isolation and monitoring them and individually. It's really to correlate the information. And I think there was, I can speed up, but I can run back to.
Can I try to answer this thing?
Yeah, please.
This comes under the realm of what we call system of systems.
Yeah.
And if you look at just in our practical life, we look at the weather report, and you think probably the guy there in the studio is just presenting that one. But if you look at, you have the satellites, you have the so many different um, appliances which are really providing and adding that one in terms of the integrated result. Same thing for the medical, for example.
Right.
You have the pressure and temperature and all those things, those sensed together, and they are integrated in the display so that the nurse or the doctor can look at. So when you look at what are the correlation data, they all relate to each other so that you can come up with a decision. I think this probably might be at least some input for you.
And the other point is that I think the question was referring, so what's different between 1G, 2G, and then 5G? Well, initially we didn't have these types of faster transmissions. You could do it manually. You could do it over on your head, and you could build systems around it and come up with similar results. All the data, the generation of 3G and 4G helped to bring about some level of automations and collecting that information so that you could see the data side by side. But also 5G came in to do much better level of correlations and have algorithm to be able to establish much more insightful, to generate much more insightful informations. So these are the difference that you do it manually and then you semi-automatic, and then as you move forward, you advance in terms of how you correlate data.
Julian, you want to ask your question, or I can read that? Julian Morales has it. Yeah, go ahead.
Yes, you're talking about a lot of data you want to collect, but what is your opinion on the status of the telecom infrastructure to meet the demands of this data collection?
Okay, so again, it is a hierarchical systems. I mean, I came from telecom, so and I really witnessed that firsthand. So
I'm a telecom engineer.
Pardon me?
I'm a telecom engineer.
Oh, okay, great. So I witnessed all the way from crossbar, I mean, connecting to generate circuits, all the way to start building these systems for telex and message switching to voice switching and on all of these type of switching systems. And I was called upon to build the telecom management for telecom operators. And essentially, you need to tap into these initially, depending on the era that you live in, tap on these systems, whether it is telex or individual type of standalone message switching systems, and get the data to ensure that you have operational data. And so initially, how much data, it's really being contained in each individual subsystems. The correlation or the data that's being collected and put into what is called the cloud or big cloud is really going to the higher level. And that's where you have tons of data, but how you're organizing the data, how you correlate the information from one subsystem to the other, really that's where it makes the difference. So when it comes down to telecom, if you are having, and this help a lot in terms of localizations and identifying where the problems come from. If it is a cut in the cable, let's say, and if it is under the ocean type of cable, then you will see it detected right away in the physical type of environment. You will see a cut, impact, for example, the transmission of that area. You could see the circuit being impacted. So if you have the connections of how each component and the impact this would have and the services impact, you could help reroute the faulty area and maybe switch to another cable or another branch of cable, or let's say another subsystem, for example, in that case, or alternate systems that could be that is a standby. So these are helping the data that you are collecting as important to help for fail-soft, for switching in case of redundant, using redundancy type of approach, or in terms of rerouting, or in terms of collaborative or correlating information from these systems to come up perhaps with a new type of emergency type of scenarios, such in the cases of, let's say, disasters or things like that. So telecom itself witnessing a lot, and there is a heavy load. And yes, they are stressed in terms of not having sufficient resources, not having really upgrade their systems to how would we migrate from voice systems to much more advanced systems, AI based. It takes time, but it will, and you probably will see a hybrid approach, meaning that there will be a system that's based on new technology, and let's say in 5G, while you continue maintaining 3G and 4G until the adoption of 5G is much mainstream, then you see automatically the transition as well as the phase out of 2G and 3G. So we start seeing a lot of phase out of the previous generation, previous systems, but focus a lot more on the new generations. So you transfer the data, you allocate now, you have more sensors, more systems, etc. So you're moving to a new level of operations. So that's really what it is. Painful, but it is also capital intensive, but it does require a lot of collaborative work. But as you see in the past, let's say putting a DMS switch, which could be a multi-million dollars, it is now half of it is virtual, half of it is really new technology, and so on. So you will be sharing the new systems and sharing the capital expenses cost, I should say, and among different, let's say, operator for sharing. And so there will be new models, and now they are going through a lot of pains, and a lot of people, a lot of telecom are still trying to figure out. The other thing I want to stress, a lot of telecom operators are, although they have been facing on speed and service delivery and so on, now they are confronted with what I was showing here, services. How would we help people to administer their IoT for the home to ensure that there is a smart home or smart grid and so on? Telecom are not prepared for that, and they may have to rely on outsource these things or collaborate with other entities, content provider, for example, and so on. So there will be a new business models that really help in the future to help administer these things. And telecom, essentially, either they could stay and providing the pipe and the speed and reliability, or also engage in terms of delivering services and and rely on where they feel their passion and comfort and deliver these particular type of service. So there is an interesting type of scenarios of models for telecom, but it may evolve to different things that what we have today.
Dr. Raja, you had some comment you want to make? Dr. Yasin Raja. Okay.
Not really, just wanted to thank Fawzi Behmann, that really wonderful, and it's giving the connection between the past and the future, and how all these multiple technologies are being integrated and moving towards forward, addressing the situations such as COVID and all that. Once you look at that, really, the IoTs, as the market is growing and the approaches, but also behind that is enabling technology, the old telecom and the devices, and starting from the wireless to fiber, and everything is behind that. So with that, really giving such a nice and wonderful overview was very fascinating. I really appreciate that, and thank you very much. Really.
Thank you very much, Dr. Raja. And
Thank
I
you.
just want to add one point that that really helping us as individuals, and I mean that will come more in 6G, but the whole notion of personalizations. So you start seeing with teleservice, telehealth and teleservice, you started seeing people, doctor calling you and set up a session for you and so on. This is really beginning of infancy of personalized type of service, but that will become more and more evidence, and that will be in every sector. So all I wanted to say, whether transportations or dealing with other types of services, different sectors, all I wanted to say is to encourage all of us to, hey, live the moment, enjoy the journey, and not to take it as a headache, but it is really seems to be a wonderful and journey, the adventure that we waiting for us to take part in.
Yeah, to add to what Julian wanted to know, I think that there's a trend, Fawzi, to from the same angle as a service to humanity. First thing is, before the event occurs, you need to come up with the infrastructure to mitigate that one. And then the second infrastructure is post-event, how you can help. And so what they have done is, from the communication standpoint, I was working many years ago on one of the Japanese plan. And what they had was, they had a special satellite that will cover the whole area and actually do the warning and then provide the support in terms of really pre-event mitigation and post-event help. That was. So basically that's what. So infrastructure, communication infrastructure has to be integrated with what Fawzi has been presenting to make this thing a viable solution to that one.